Okay, now I'm going to cover how to calculate the distance from a velocity versus time graph. So imagine a simple velocity versus time graph, and time is plotted on the horizontal axis and velocity is plotted on the vertical axis, measured in meters per second to keep it simple. Let's say that an object is moving with a constant velocity for a certain duration of time, and for simplicity's sake we're going to say an object is moving with a velocity of say 10.0 meters per second, and it's constantly moving with the same velocity for about say 8.0 seconds. Then according to the formula, we know that velocity equals distance divided by time. Therefore, distance has to be velocity times time. The product of velocity and time is actually the displacement. So the time in this case is 8 seconds and the velocity in this case has been 10 seconds. So displacement is 10 times 8, which means the displacement will be 80.0 meters. Now you can see that this also works with the units, that the 10 meters per second and 8 seconds, when you multiply meters per second, the units also match. So the rule is that if you look at the length of this graph, it's actually the time, 8 seconds. And if you look at the width, it's 10 meters per second. So even if you had seen this rectangle and calculated the area of this rectangle, that would have also been 80. So the rule is that you use the area of a velocity versus time graph to calculate the displacement. Now this rule works even if the figure were not as simple as a rectangle. And let's assume that an object is moving with a uniformly increasing velocity, meaning let's say that originally at 0 seconds the velocity was 0, and at 8 seconds the velocity actually became 10 meters per second. Now that 10 meters per second velocity was not throughout the time. It was the maximum velocity. At 0 seconds the velocity was 0. At 8 seconds the velocity was 10. So we can say that at 4 seconds, since it was increasing uniformly, it was 5 meters per second. Now the slope tells us acceleration, but pay attention to the fact that what does the area tells you. Now if we wanted to calculate the displacement, we are not going to simply multiply 10 times 8 and call it 80. We're not going to do that, because 10 was not the velocity throughout the time. 10 was the velocity at the end, the maximum velocity. The minimum velocity was 0. Since it was increasing uniformly, you could actually take the average of 0 and 10. And the average of 0 and 10 is 5 meters per second. Now if we assume that the velocity has been moving with 5 meters per second throughout the 8 seconds, that would mean that 5 times 8, which is 40 meters, is how much the object covered. There's another way of looking at it. Looking at the graph, you see that the area under the velocity versus time graph is a triangle. And to calculate the area of a triangle, we use the formula 1/2 times base times height, which is the same as base times height divided by 2. Base in this case is 8. Height in this case is 10. So if I did 8 times 10 divided by 2, which is 80 divided by 2, that is also 40. So once again we conclude that calculating the displacement from a velocity versus time graph is in fact the area under the graph.